All right, well, thanks everybody for joining today. I think we'll get a couple other stragglers in as things begin, but if not, we can have a more dynamic conversation here. So my name is Mike Giacometti. I'm a product manager at Cloud Health by VMware. Focused in one of the areas that I'm focused in, I should say, is around container visibility and optimization. So being able to understand what's going on, not only from a usage standpoint, but also be able to attribute that to cost when you dive below the PaaS layer to be able to understand who's consuming what and kind of how much does that break down to and what are our costs and how's that all flowing. So a little bit about myself. I do come from the customer success side originally, having worked as a TAM with many of our biggest customers across the East Coast and since transitioned over to be a product manager. Have a passion for diving into data, learning new things. Our platform has a ton of data coming into it relative to cost as well as consumption, performance, and so forth. Have a strong focus on cloud economics as well as financial management. I'm a bit of a sneakerhead, love shoes, hiker, skier, also a dog lover. Happy to talk about any of those things after the talk as well if you're interested. So to spend one quick minute on Cloud Health and what Cloud Health by VMware is, we provide visibility into what you're consuming across the various cloud platforms. Not only from a visibility standpoint, but very especially on cost. We make it easy to manage the resources that are held across those different environments, layer areas of security as well as compliance on top of that, and then provide insights and analytics and a better understanding of what's going on so you can empower the right individuals to take action and then ultimately automate some of these behaviors so you don't have to keep a pulse on it entirely. So EKS, Managed Kubernetes, cool stuff, but let's learn a little bit more about it. Why would someone select EKS or go with EKS over a vanilla Kubernetes implementation? Well, you get Kubernetes, but with a managed control plane, something you can kind of hands off or take your hands off the wheel. You also get your worker nodes managed for you, which is pretty nice. Not to mention high availability. There's a serverless option that you can leverage, and there's an awesome community out there. EKS can be pretty easy. It can be a great start or a permanent solution that you might want to leverage. But the challenge is, how do you keep track of what's going on there if all of these things are managed for me? When you kind of go ahead and take your hands off the wheel a little bit more, it can be a little scarier in terms of what that actually pans out to be. What kind of machines is the actual EKS cluster spinning up, and how much do they cost me? And are we utilizing them well enough, and so forth? So yeah, how do I get that right level of visibility? You also might be in a mixed mode, right? You might be using EKS, but also other flavors of Kubernetes, perhaps a little Mesos or ECS or whatever have you. It'd be really nice to get that all in a consolidated view, right? So from a Cloud Health standpoint, what you can do is install our lightweight collector. It gets sent out or deployed as a deployment. It's quite tiny, run a handful of commands here to be able to perform the installation and leverage a YAML file that we already provide out of the box for you. There's two options. You can install it as a deployment so it'll constantly stay running. We only need one instance of it per cluster to be able to monitor appropriately and get the right information into the system. But you can run it as a regular pod as well. It's just if there's a hiccup on one of the nodes it's running on, we won't maintain continuity, but you do have that flexibility there. The last factor that most Cloud Health customers that we already know well that they have their AWS bill feeding into us. Now, if you are coming in net new and looking most predominantly for Kubernetes capabilities, that is a requirement that we need to be able to pull that bill in so we can properly attribute the cost data to that usage and perform some other kind of deeper analytics. So with that, the other thing you need to do to get the cost piece is to do or create what's called cost distribution rules. And there's a couple examples here that I put up from the environment that I'm going to walk you through in just a minute. And it's centered around specific clusters within our environment. One is a US1 prod, the other one's US1 dev. And I've been able to say, I want to reallocate the costs and whatever kind of resource costs that are associated to this cluster to namespace groupings. So you can do this based on namespace groupings. You can do it based on any custom label that you're using within that environment as well to kind of divvy up the usage as well as the cost. And the last thing is to decide what distribution method I want to leverage, whether that be strictly based on CPU, strictly based on memory. These are memory, CPU request and memory request, or some ratio or combination of the two. So if you look here for production, we've done an 80-20 combo, but on the flip side over here for our dev cluster, we're strictly basing it off CPU consumption. And from there, you get some pretty cool views like this. So from performing those types of configurations, we'll begin collecting that data and understanding what pods are running, what are their stop and start times, what other metadata is attached to all of that. We bring it all in and associate it based on what kind of groupings you've asked for selected, whether it be a namespace, a custom label that aligns to a project or an application or whatever have you. And you can break things down like this. So in this example, we're looking at the breakdown of our clusters, multiple clusters in this scenario, sliced by namespace, and I can see how the cost is trended for any one of those different groups over time. So I can keep an eye on or monitor for any specific anomalies or any strange behavior that could have taken place or things that we might want to introspect in or start to think about that we might want to optimize for any one of these different namespaces that we have in play. To make that a little bit more real, let me hop into a demonstration and walk you through some of the live screens in the application itself. Let me pop back one more screen here so we can get a higher level overview. So we recently released what's called our Kubernetes Overview Report. And this is not just for EKS, but it's for any Kubernetes cluster that you might be running in your environment and have plugged into Cloud Health. And it's giving you kind of a high-level executive summary breakdown of what's going on there, supported by a little bit more rich metadata and the status of the health of our Cloud Health collector, so you can monitor that as well to make sure the information remains flowing. You can look at this based on cluster, but also based on namespace. You can kind of switch between those two. And then some cost data to support that as well. Similar to what we just saw, I have the ability to remove or hide what's not containerized. In a lot of cases, you might want to get a full picture or see everything that's going on there, right? But then I can kind of add or remove whether or not I want to incorporate that. So now I'm getting a look at what cost has looked like on a daily basis for these different clusters that I have, even including an ECS cluster in this case. Funny spike here, which is interesting. I actually know the explanation for that, but that would be something you'd want to go in and research, perhaps, based on looking at this information. In this case, this has to do with reservations, and reservations burn down over time when you purchase RIs with Amazon. So at the start of the month, you have this big chunk of unused that ends up being consumed over the course of the month. So I just happened to know that, and I did a little research before popping in here so I could explain that. But that would be something I'd want to double-click into and introspect, better understand like what the heck that is and why is that happening. So to that end, let me actually click into this report. This is very much kind of like a launch pad that can allow me to go in and learn about more things, go a little bit deeper and understand. In this case, I get the very same visualization that I had previously. However, the difference is I unlock many more filters, categorizations. I can change the time series of the data if I want to. I get some more flexibility here if I want to go deeper. In addition to that, I can actually click into some of these line items in various reports and get line item detail breakdown of what makes up these aggregated bars. From there, I can also dive into other cost views. In this case, this is a monthly view of that, the really very same report that we were looking at before, filtered only to the actual clusters themselves associated to Kubernetes, so the non-containerized stuff I've filtered out of this report. And now I can see month over month how my costs have trended. You know, we're in December and just the beginning, so we're looking small right now, but this will continue to grow. But it looks like we've either made some serious optimizations or at least changes or migrations from this ECS prod namespace cluster being switched into US1 prod. We see some growth here, but also some, dollars and size changes for that second month there. But then beyond the actual cost data, I would love to hide that. There we go. I can also look at, here's a daily view looking over on the scope based on namespace. So now I'm getting those dollars attributed like I created those cost distribution rules to associate cluster costs based on the consumption per namespace. I now have that breakdown laid out over time, and I can understand my ebbs and flows, what's going on there, and decide if I need to go introspect, learn something about this, see what the heck's going on, and kind of can highlight that. All of this data is also supported by tabular-based data down below, which is true for both our usage reports as well as our cost reports. And then finally, if I take a step back to the Kubernetes overview report, I can also drill in from a usage standpoint for any of these. So if I wanted to look in namespaces in particular and dive into any one of these specific namespaces, I could say, let me go look at my budget namespace and see what's going on right there. Or someone wants to learn more about this. It'll tell me how many clusters it spans, the nodes associated in pods, and it's supposed to generate analysis data there where it actually shows me what used CPU and what used memory has looked like or transpired over time. I can very similarly do that same thing across clusters as well, which gives a little bit more data beyond this, but it kind of gives you this opportunity to be able to demystify the abstraction that EKS provides to you and be able to fully understand what's going on there. And then you're not doing that in isolation, right? You're doing it amongst your other Kubernetes clusters if you're managing a mixed mode across your environment and getting one single pane of glass view as far as usage as well as cost is concerned. So that's it in the way of presentation. Happy to take any questions or talk about this a little bit more if you're interested.
So I assume you're looking at aggregate costs across the AWS resources that are supporting the cluster. Am I making that assumption? Or, for example, if I'm operating a cluster that's mounting a whole bunch of EBS volumes, right? Is Cloud Health able to make that inference that these the costs accrued on those EBS volumes are supporting a certain cluster or a certain namespace? Or is that up to the user or the operator to label those resources in a way that would be conducive?
Great question. So in Cloud Health, there's this concept of what we call perspectives, which allows you to make rule-based groupings to group your assets. And that's largely plays a big part in these capabilities. To accomplish that or to do that, you would write, it can be based on tags or any other metadata that you have going on there. And we also have this concept of a gather tree. So for example, if you use specific groupings, you can state any resources and they're attached or like family. I don't know what the word is escaping me right now, but those resources that are like just directly associated to instances, for example, like EBS volumes or some load balancers or whatever have you, you can incorporate those all into your group, which would amass the overall cost of that cluster. So you could say for like US Prod 1, not only does it include these actual machines that are doing taking on the compute, but here's the attached storage for it, here are the other resources that are part of that too. And then when we do that cost distribution breakdown, it'll factor in the costs of those resources as well and slice them as part of that. So it depends on what you'd like. If you want to strictly look at it from a compute standpoint or you want to look at it from a total cost point of view, you can do that too. And then you can actually leverage one of our categories and slice, for example, a cluster based on service items, AWS service items. And then you could see the composition of that cluster based on the service items and the dollars that are associated to that. So it'd be a configuration choice ultimately, but you could accomplish it either one depending upon your need. Any other questions? All right, well, thank you for your time.